The functions of the complement system, there's a great figure, it's figure 7-1. And this one demonstrates what the complement proteins can do. Complement can bind together and punch holes in the membrane of invading cells or foreign cells, and thus destroying them. You punch holes in them, they lose cytoplasm. If they're bacterial cells and they get holes punched into them, not only do they lose cytoplasm, but they lose the ability to produce a proton motive force, which is how they make energy. So that weakens the bacteria. They can also act as opsonins, binding the surface of bacteria or other foreign invaders and increasing the phagocytic activity toward them. The complement receptors can be found on the outside of white blood cells, especially phagocytes. So a fragment of one of the complement proteins can bind to this complement receptor and increase the activity of that cell. It can also increase the movement. Usually the binding of complement proteins to the complement receptors are not permanent relationships. They're not covalently bound. A protein will jump on and then it'll jump off. So it's like your sense of smell. If I blindfolded you and I put a pizza in the back corner of the room, then you could probably find it by noticing that the concentration of the smell was thicker in relationship to the location of the pizza. So that's kind of what happens. So in that sense, it can not only increase the activity of the white blood cells, but it can cause extravasation, which is the movement of the white blood cells, especially out of small capillaries into an area of tissue damage. Many of the granulocytes will have binding sites or receptors on their surface as well, and it can cause degranulation. Sometimes it may be kind of a threshold event where it requires a number of these complement fragments binding to the receptors on the surface of the granulocytes to stimulate them to release. So one or two, they're not going to release many of those little packets of stuff. But if they get a large number of them, once they reach that threshold, they'll start releasing them. Pardon me. The last of the effector functions, or the actual functions of the complement system, is they can help to clear immune complexes. Sometimes when you have antibodies out there, they'll bind to different antigens and they'll start clumping up. Well, those need to be cleared. So a antibody with a bound antigen will expose a binding site on its stalk, or the Fc area of the cell, that the complement cascade proteins can bind to. When they bind there, then they stick to a phagocyte. The phagocyte can consume the antibody-antigen complement complex, and they remove the antigens, they remove the complement, and they spit out clean antibody to go out and do its job again. So it's kind of a way of recycling these weapons, these tools. Okay, so they can lyse cells, they can opsonize different foreign invaders, which improves the phagocytic activity. They can bind to receptors on several different kinds of immune cells and increase their functions. They can cause degranulation of granulocytes, which can stimulate inflammatory responses. And they can be involved in clearance of immune complexes, like antibodies that are bound to their antigens. Now, the components of the complement system are fairly easy. They're soluble proteins, some of them are glycoproteins, but they're usually fairly small. They're made in the liver, so usually hepatocytes will make them. And they are fairly easy to name because they're called C1 is complement protein 1, C2, C3, C4, C5, etc. Now, what happens, though, is when these things fragment, one piece of one of them can bind to another piece of another and form a new complex protein. Ugh. Okay. So, complement components can degrade, bind together, and form brand new complexes that have a different kind of role in the formation of complement cascade activity. Let's see. So it's kind of like an enzymatic cascade. There are three different ways that the complement cascade can be activated. One is through a classical pathway, one is through an alternative pathway, and the third is a lectin pathway. I will talk about those in a separate audio clip here in just a minute.